This is CGTN, China Global Television Network.
Hello and welcome to this Razor COVID-19 special. I'm Emma Keeling. Herd immunity is the term used to describe the proportion of a population that needs to be vaccinated in order to control an infectious disease. Measles is an example where most of the population is vaccinated, which in turn protects those who are not. However, the World Health Organization has labelled herd immunity a dangerous concept when talking about COVID-19. I spoke with virologist Dr Jeremy Rossman and asked him if he agreed.
The concept of herd immunity is something that happens within a population. This is not a public health strategy. And when you try to start thinking of using herd immunity as a public health strategy, then it becomes very dangerous. Because the way in which herd immunity is being discussed as a strategy is that the virus goes through the population and ends up infecting between 60 to 70 or perhaps even 80% of the population, and then dies out, and then the population is safe from the virus. Now, this will cause a tremendous number of fatalities, critical illnesses, hits to the economy. This is a devastating approach. Now, all the public health strategies of testing, tracing, isolation, these are very effective, but they don't eliminate the virus. And that's one of the concerns, is they don't eliminate the virus, but they keep the transmission so low that we are not even close to the level of herd immunity. And so this is not a necessary approach, nor is it a safe approach, nor is it even an economically viable approach. We should not be discussing herd immunity. We should be discussing testing, tracing, isolation. Herd immunity, maybe we'll get there someday, and if we get there, it should be through a vaccine. But we don't know enough to know that's possible, and this is not what the conversation should be focusing on right now, and definitely not what public health strategies should be.
But do we even know if we can have immunity against COVID-19?
This is a crucial question, and we don't know for certain. Now, we have had some recent studies that have shown that the vast majority of patients that are infected with COVID-19 and recover show very strong antibody responses. Now, just because you have antibodies doesn't mean that they protect you from infection, but it's a good indicator. And with the very related SARS virus from 2002 to 2003, we did see that that virus produces protective immune responses that last at least for about 2 to 3 years. So the evidence strongly suggests that we will have protective immunity, but we don't know for certain that that's true, and this can change from virus to virus and person to person. So we still need to confirm, but it will most likely be true.
So you may build up immunity to one strain, but possibly you wouldn't build it up to another, is that correct?
This is always the concern with any virus, because viruses tend to mutate quite quickly. And so if you take the flu, for instance, this is why you need a new jab every year, because the virus changes so much. So even if you're immune to one, by the next year, you're not immune to this new variant. But COVID-19 and coronaviruses don't change nearly as fast. We are seeing mutations within the virus, but there's no evidence that says that these mutations are sufficient for the virus to evade the immune system. So it is possible, but I think there's a really good chance with coronaviruses and with COVID-19 specifically that we will be able to generate an immune response that does last, that the virus won't change fast enough to escape our immune system. But again, we don't know for certain, and this is a crucial factor.
What more information would we need before we could even entertain this whole herd immunity thing?
What we really need to know is if somebody has previously had COVID-19 and recovered can then be reinfected. Now, there's some discussion about human trials, about vaccination and then exposure to see if, in fact, people can be protected. But also, as we start to look at countries that have had COVID-19 for multiple months now, if we start to look back in China, and we're starting to see more and more cases occurring in the country, even now that people have been immune, it's important to go and say, is anybody being reinfected? Or is this just still a low level of virus transmission in the country? Right now, there's no evidence that actually says reinfection. But it's that crucial area is that you can look at antibody responses, you can look at how these antibodies behave in the lab, and we've done that. And we have very good data that says these antibodies respond to COVID-19, these antibodies can block COVID-19 infection in the lab, and that's great. That's a really good indicator. But in the end, what we really need to see is that people are protected from reinfection. And this virus is just so new right now that we don't have that data yet.
As lockdown restrictions ease around the world, but we remain cautious of subsequent outbreaks, people will start walking, running and cycling more often. A Dutch-Belgian study has mapped the flow of particles we breathe out to see how they are affected by rapid movement. Shini Somara reports.
Air is invisible to us, and so are viruses. So to visualise how COVID-19 could spread through air requires the use of computational fluid dynamics, or CFD, to predict, using mathematical equations, how air flows.
What we normally do is we study airflow around buildings, around athletes, around runners, around professional cyclists and so on. That is the gap that we try to fill partly with our work, is to see, okay, what if you are a professional athlete, if you go training, maybe cyclists, they go out for 5 hours, 6 hours, 7 hours per day. You're riding constantly in the slipstream of another person, so you're riding constantly in a droplet cloud. So the situation will be different, and that's also what professional athletes say. They say in cycling, there was last week a very nice interview by a top Dutch cyclist who said if on the first day of a multi-stage race one rider has the flu or has a cold, a few days later the whole peloton has this cold. And that's actually a bit empirical evidence of also the research work that we did.
Fluids are either liquids or gas, and the way they behave can be mathematically modelled. Essentially, a mesh or grid is applied to the objects or space being simulated. At each intersection of the mesh, called nodal points, equations provide answers to the speed, position, temperature, and various other characteristics of air. Simulations are often validated by comparing them to real scenarios that have been set up in a wind tunnel.
Our intention was to see what is different when you are moving in terms of movement of droplets around you. So this social distance, or actually it's a physical distance that has been determined, that is in some countries 1.5 meter, in some it's 2 meters, in some it's 6 feet. That has been determined actually about 20 years ago for two people standing still and talking to each other, somewhere where there's no wind. And that makes sense because most of the droplets that you exhale or that you can cough or sneeze, they don't travel further than 1.5 meter, and if they do, they will probably land on the ground and not on the face of the other person. But when you're moving, things can become very different. When you are moving forward and you're exhaling droplets, the droplets actually are very light, so they will not keep moving along with you. You will actually leave them behind you in your trail. So if other people actually are then walking towards this droplet cloud, they can actually also walk through the droplet cloud. So this means that this social distance that we now know will not be the same, will not be this 1.5 meter or 2 meter when you include rapid movements.
Can you define what a small droplet is?
So when people are exhaling, every time you exhale, you also are emitting droplets. And these droplets can be very small. They can even be smaller than a micrometer. So that's 1/1000th of a millimeter. And that's also the reason why you can't see them unless you use special lighting. I think the power of simulation is that it visualizes often items we can't see, like in this case the airflow patterns and also the movement of droplets. We wanted to provide an answer to the many people, by the dozens actually, that have asked us, how, when I go cycling or running, how should I overtake another person? Should I hold my breath? Should I walk in a big detour around them? Should I just avoid overtaking? Is it okay when I cross somebody? And that's actually what we determined, and what we actually found is that these droplets remain quite confined in a relatively small area, the slipstream. That is where the airflow is disturbed by the movement. That is actually called the slipstream or the wake. And so it's actually an area behind you with lower pressure, and this lower pressure actually also helps in containing the droplets there. So it's fine if you overtake a person, but just avoid what cyclists like me also do all the time. You want to be in the slipstream, and there you have less air resistance. Here the message is just the opposite. Just stay out of the slipstream. And then it's perfectly fine to overtake a person. It's perfectly fine to be cycling even when it's a little bit crowded, as long as you stay out of the slipstream. At least don't stay in the slipstream for a long time. It's fine. If you go running or cycling two next to each other, there is no problem at all. And so all the areas around another person are fine, except the slipstream.
There are still a lot of unknowns on possible transmission routes. Variables such as wind direction and speed can also have an impact when outdoors. Other factors such as exposure time and being in an enclosed space also increase the likelihood of transmission. No distancing guidelines are thought to provide complete safety, and for those considered high risk, it's recommended to stay home and isolate.
Try not to walk behind the same person for a very long period of time. Don't remain in the slipstream for very long. And that's why actually our work was really geared at athletes and people practicing sports, where you do have that for quite a long time. And we should make it a bit harder for ourselves, be out of the slipstream, a bit more air resistance, but cleaner air. I also got many comments from people saying, well, we live in a city and it's very crowded here and we cannot keep that distance all the time. But I think that's also not necessarily an issue if you're just walking around. The issue is actually with fast movements, where these droplets are in the slipstream. We're all in this together. Let's be a little bit extra nice to each other. It's not that people that are running and cycling are spreading the virus more than others. I think if we all give each other a little bit of space, literally and figuratively speaking, I think we're already a big step forwards in this pandemic.
The whole world has its hopes set on a vaccine against coronavirus. In the UK, an effort led by an Oxford University team has begun human trials with the cooperation of research hospitals around the country, such as St George's in London. 1,000 volunteers have been injected, half with the proposed vaccine and the other half with an already established vaccine. This is what's known as a double-blind trial.
Half of the people who are in your study aren't getting that vaccine, are they?
That's correct. Half are getting the control vaccine, and the control vaccine that's been chosen for this trial is a meningococcal vaccine, so against Neisseria meningitidis. And it's a very safe and effective and commonly used vaccine. It's used in the adolescent program in the UK, and it was really chosen to be the control vaccine because of the knowledge about the safety and efficacy of this, and also because the great majority of people in this trial won't have received it before, because the adolescent program's only relatively recently started. So it will be of potential benefit to them. But even if they have received it before, there is no concern or harm in receiving another dose in the context of this trial.
So that's really where we're at now. You're trying to find out whether it's safe to put this thing into people.
Yeah, that's right. Exactly right. The phase 1/phase 2, because in fact, this trial is combining elements of both. It will determine at this point whether there are any major common side effects that we need to know about before moving on to the phase 3 and ultimately implementation to the population.
There are 1,000 volunteers. Exactly what are they being given?
The delivery, if you like, of the protein against SARS coronavirus 2. And this protein is called the spike protein, and it's an essential protein in the way that this virus infects human cells. So it's generally believed that developing immunity against this spike protein will prevent disease occurring. The spike protein is being delivered by an adenovirus vector. And an adenovirus is, of course, a virus, and indeed it's a common cold-like virus that occurs frequently in the population and is generally very benign. In fact, for this vaccine, the adenovirus that is being used is one that infects chimpanzees and not humans. And the reason for choosing that is that many adenovirus vectored vaccines have been used in the past, and they work well, but if the human has pre-existing antibody or immunity to the adenovirus, then it interferes with the way that it works as a vector, a way of delivering the immunogenic protein that we're interested in. So that's why this particular adenovirus has been chosen, because there is no or very little pre-existing immunity in the human population. But these are non-replicating viruses, so they don't replicate. They're just a way of delivering, in this case, the spike protein.
Elisabetta Grappelli is a volunteer and a virologist. Thank you so much for joining us. You've just been jabbed with a vaccine.
Yes, I have.
But maybe not.
Well, it is a vaccine. Definitely I got a vaccine. What I don't know, what not even the medical doctors involved in the trials I took part of know, is if I have been given the vaccine against the COVID-19, so the SARS coronavirus 2 virus, or if I have been given the control vaccine.
How do you feel?
I feel fine, absolutely fine. If I hadn't had to, remind myself to measure my temperature, for example, or, asking myself how I feel, business as usual, pretty much.
So no side effects at all that you've noticed?
No, of course, I cannot speak for anybody, and this is why the thousands people clinical trials will, be giving bigger pictures about potential side effects of the vaccines. But I can speak for myself as a volunteer, and yes, all fine for me. Certainly no side effects that I am aware of.
Now, I had a friend who was accepted to be screened for the trial, and when she told her family, I'm going to do the vaccine trial, they all went, "Are you mad? What are you doing?" Did you have any similar things from your family?
Yeah, a bit of both. My mom was very supportive. She said, "What about us over 70s? Can we take part?" And I said, "Mom, this is only 1855, okay? We just want the healthiest people and a little bit younger than you right now, but hang in there." My dad had "Yeah, okay, you're a bit crazy. I'm not sure about that." To which I just respond, "Dad, it's not just a vaccine, it's a viral vector. They've engineered a virus, as they know everything about it. I can explain the molecular details to you. Don't worry, I'm happy to participate into this."
So when will we know that this vaccine is worth starting to manufacture?
So the University of Oxford, which is the brain and the hands behind this particular trial, has talked about September. So September will be the good time to see if the vaccine has generated a strong immune response, and if that response is specific for this virus. So yes, it's a few months.
It's a disease that could attack anybody.
Life under lockdown.
And I'm Rahul Pathak.
It comes as a shock to all of us.
So I'm in home isolation. I'm Isabel Ewing in Budapest.
We have a simple message for all countries. Test, test, test.
After schools shut their gates from Friday.
We are accelerating research.
I said very clearly there's more to do.
Develop a vaccine.
You were the eldest person to have survived this nasty virus.
Thank you so much for all you people.
Don't forget you can sign up to our daily newsletter. We bring you all the top business headlines straight to your inbox. So sign up for free at this address. CGTN. See the difference.
COVID-19 is a respiratory pandemic. It causes death primarily through pneumonia. But according to emergency medical practitioner Dr Richard Leviton of New Hampshire, COVID can be confusing because patients presenting to hospital can have severe COVID pneumonia and yet not feel short of breath.
So COVID pneumonia is a type of pneumonia, but the dangerous thing about COVID, the thing we didn't appreciate when it started, is that patients can be very far along with severe COVID pneumonia and not feel short of breath. And so even though their x-rays look terrible, they have severe pneumonia, even though their oxygen saturations are incredibly low, like so low that we are amazed they are talking to us, they can be as low as 50%. That combination of advanced disease, incredibly low oxygen levels, and yet the patients are awake and talking is something that we've not seen ever in medicine. And certainly not all at once, hundreds of people in the same emergency department at the same time. But it is the silent nature of the way the pneumonia advances, and the patients do not feel short of breath until they get very, very sick. So we have to change our public messaging, I believe, and we have to change our management so that we can get earlier diagnosis and we can get patients diagnosed earlier and treated earlier, and that way we can do a lot better for them.
Dr Leviton believes that one way to achieve this earlier diagnosis and treatment is through the use of a simple and readily available piece of medical technology known as a pulse oximeter, which costs around $30 US.
So a pulse oximeter is basically considered a fifth vital sign in hospital. It measures oxygen saturation in the blood. And there are consumer models like this one that clip on a finger and are essentially very reliable. They're offered widely in pharmacies. And it is routinely used by lung specialists to manage patients who are on chronic oxygen and have known lung disease.
But could there be problems which arise as a result of self-monitoring?
I don't see any downside as long as patients understand that this is just one tool that we use. But in the decision-making of who comes into the hospital for pneumonia, for instance, it is one of the most important tools we use. So having this information that you can share via telephone with an emergency department or with a primary care provider is enormously valuable. There are some preliminary studies that have happened in the States showing that elderly people who are more closely monitored get diagnosed earlier and do better. I received an email from a colleague in Italy recently, and he explained to me about their use of oximeters in COVID patients. They identified these people earlier in the disease in the emergency department when they had muscle aches and fevers and other things that made them suspect COVID. They confirmed they had COVID. They sent them home with these oximeters. And only 1 in 20 of the patients went on to develop COVID pneumonia, but they detected it early with the oximeters. So 5% of the 250 patients came back with low oxygen, but they all got treated early and they all did well and they all avoided a ventilator. I believe if we have earlier diagnosis, we will get patients better, sooner, and more effectively than waiting until they come in very, very sick.
Cross-species transmission, or spillover, is the most significant cause of disease emergence in humans and other species. Professor Richard Koch is an infectious diseases specialist. He believes we need to reform our agricultural practices and our whole relationship with the natural world. He begins by telling us about the Nipah virus outbreak in Malaysia in 1999.
So the Nipah virus spilt over from bats, and we have a clear understanding of that. So we do know that that is the case. What happened was that they started agricultural development in certain areas associated with bat populations, and these were a combination of fruit farms and pig farms. And yeah, as we tend to do, we think about the production and the benefits of having these things together, in an agricultural context. But nobody really thought about the ecological consequence of doing that. In other words, what would it do in the contacts with the natural environment? And what it did, quite logically, is that the bats, who had lost quite a lot of their land to agriculture, were looking for food. And there was the food, produced very nicely by humans, very neatly in rows, fruit trees that they could then go and feed upon. You can't blame the bat for doing that. He's lost his natural products. So he went and did that. And in the process, he, leaves his defecation, his urine, and these fruits then were given to the pigs or fell into the pig pens. The pigs then ate them, enjoyed them rather, and then got infected by the virus. The virus was able to infect not only humans, but also pigs. And in the process, of course, people would come in to tend the pigs, and then the virus got into the people. And then the people went home and then transmitted the virus to their families. And so there was a big die-off people and, a lot of concern and worry. But to resolve the situation was pretty straightforward. Don't grow fruit trees around pig farms, because that was the transmission pathway. It was clear. So once you understand that, you can change your management. And in that case, they have. We're sort of learning where human behavior and human infrastructure change and agricultural practice is increasing risk of these things. And we just need to manage it and ensure that this doesn't happen. But it needs to be part of our development. What has happened in the past is that we've just responded to these things, so that, when you get an Ebola outbreak, you say, oh my goodness me. But instead of thinking, well, actually, why has this happened? What is it that we are doing? What is the process that leads to this? And then addressing the process in our development. So I think we need to shift that. It's just the nature of humans. We're not that good at preparing for things and using what I call the precautionary principle. Don't do dumb things, basically.
Quite a good rule.
Yeah. And that's really, I think, where we need to shift. I don't see the solution to this problem of emerging diseases from technology. I don't see that vaccines will solve it. Lots of fancy, pieces of equipment and treatments. That is not the solution. If a domestic animal was just another animal in the forest, and you do get some societies, if you look at traditional societies, that's what you have. And there's not a problem. But if you put 1 billion chickens next to a flyway for, wild birds, it's quite possible that a virus will get into that, billion chickens. With the coronavirus, if you, put bats somewhere near a farm of, say, raccoon dogs or civet cats, which are used for fur, so these are in their millions, then the virus has a chance to replicate and adapt and then spill into humans, which happened with the SARS epidemic in 2003. So it's what we do actually that generates the problem. So we have to balance our economic benefit from using these intensive systems with some of the risks.
It sounds like you can sum it up by saying a lot more respect for the natural world.
Yeah, the thing is, the natural world works. There are certain challenges, I think, with the natural world, but it teaches us that it has, in a sense, evolved to give everything a chance. And, so nothing too dramatic ever happens in that sense. And you will get challenges, you will get problems, but the species will adapt to that and will have time to adapt to that. Whereas, with our transformed landscape, where we take advantage, if you like, of that biological resource and turn it into, say, meat or fur or something, we really unbalance the whole system. And the product, it seems, is often emerging pathogens. So we do it at our peril, I think.
That's it for this Razor COVID-19 special. Stay safe, keep your distance, but definitely look after each other. And we'll see you again next time.